Okay, so today let's take a look at this LeetCode challenge problem, carpooling. So you are driving a vehicle that has capacity empty seats initially available for passengers. The vehicle only drives east. It can turn around and drive west. Okay, so given a list of trips, trips I has three elements: number of passengers, start location, and end location. Okay, so this trip's I contains information about the I trip, the number of the passengers that must pick it up, and the location to pick them up and to drop them off. The location are given as the numbers of kilometers due east from your vehicle's initial location. Return true if and only if it's possible to pick up and drop off all the passengers for all the given trips. Okay, so here are some constraints. It defines the number of trips and also defines the range of the start location and end location. Okay, and capacity. Well, how can we have a car has like so many available seats? Anyway, okay. So in the first example, we are given two trips, right? So let's see how it works. Okay, so this is like our timestamp or location stamp. Okay, so at 1, we need to pick up 2 people, and our capacity originally is 4. So after picking up these 2 people at location 1, so our capacity will be 2. Right, the next position where we have people drop off or picked up is location 3, right? And location 3, we need to pick up 3 people. So yeah, we don't have enough capacity, so that's the reason we return false. Okay, how about the example number 2? Example number 2, inputs. Okay, inputs gonna be the same as the example number 1, but capacity in it's 5 now. Okay, so this is our second example. So now our capacity is 5. So the first place where we have capacity change is at location 1. At location 1, we have 2 people going to be picked up, so our capacity will be updated to 3. The next location we have capacity change is at location 3, and after picking up 3 people, our capacity becomes 0. Right? Then the next position where we have capacity change is at position 5, where we will drop off 2 people, so the capacity will be increased to 2. Lastly, we're gonna drop off 3 people at location 7, and our capacity, we're gonna jump up 3 people. Yeah, our capacity will recover to 5. Okay, so as we go through these 2 examples here, what I'm thinking about is we somehow need to sort the location, right? We need to sort the location and then keep tracking of the capacity change. Anytime when we find a position that the capacity is less than 0, we know we don't have enough seats available, so we return false, right? So how can we sort the location? I think we can use a built-in data structure, sorted dictionary. Our sorted dictionary will have key value pairs, and the key gonna be the location, right? And the value will be the value will be the capacity change, right? After we building this sorted dictionary, we do a one pass to check whether at any position the capacity will be reduced to negative. If that's the case, we return false. Okay, let's code it. Okay, we need a sorted dictionary. Then we just iterate the trips, right? Okay, so if we are at the start position, it's gonna reduce our capacity. And if we are at the destination, we're gonna increase our capacity, right? Our start position gonna be trip 1. This is gonna be our number of people, right? This is gonna be our capacity change. Okay, now let's handle, so this is the pickup. And now let's handle the drop off. Okay, at drop off location, the destination location, we're gonna increase our capacity. Right, after having this capacity change, we just do a one pass, see whether at any position, location, we have capacity decreased to negative. If that's the case, we return false. Okay. By default, we return true. Okay, let's run the code. Okay, so let's try another example. So this one seems more complicated. Capacity is 11. Okay, let's submit it. Okay, accepted. Okay, only beats on 26% of the C# submission. So what's the time complexity about this one? Okay, that's fine. So so since we are using the sorted dictionary here internally in C#, is sorted dictionary is built on top of the tree, right? Tree data structure. So adding a node into the tree gonna take log n o n time, log n time complexity, and since we have n trips, so essentially our time complexity will be O n log n, right? So this is our time complexity. And the space complexity is basically going to be the maximum number of data we stored in this dictionary. So it will be a big O n time complexity, space complexity, yeah. Okay, so can we improve this solution? Yeah, what I'm thinking is like, so we are using a sorted dictionary to sort the destination, right? So, and also we know the destination is between 0 and 1000. So I think we can use array. We can use array instead of the dictionary. If that's the case, when we add the data, we're gonna use O1 time complexity instead of log n, right? Okay, I think let's give a try. So yep, we allocate memory, have 1001 spaces, and we just go through these trips, iterate these trips. Right, we also need to keep track of the capacity change. So here we track the number of people that picked up and drop off. So same as before. This is going to reduce our capacity eventually. Since this is our start location and this is our lumber people. Right, so this basically says at this particular location whether our capacity will be decreased or increased, right? Depends on whether we pick up or drop off people. Yeah. Then we keep updating our capacity. If capacity is less than 0, we return false. Otherwise, we return true. Okay. Let's run this example 4. Okay, let's submit it. Okay, so it improved a little bit. So the time complexity of the second solution, as we can see, is basically a two-part solution. So the time complexity it's gonna be O(n), right? And the space complexity, we allocate a fixed size array, so it's going to be O(1), right? Okay, so yeah, that's it.